Okay, welcome to Unit 4. Right now, first part of this unit, we're looking at the meaning of derivatives. So this video, this section is going to be mostly review, but this is kind of stuff that you have to get down, have to know before we move into, the more harder, more difficult stuff, right? Because Unit 4 is when we kind of start getting a little bit hard. So the meaning of derivatives, obviously the derivative of a function is the slope, right? And the slope of a function is the change in y over the change in x. I'm sure you guys have seen this before, delta y, delta x. This kind of review, we're going to go over it quick. So the derivative of a function is obviously the slope. And the way that you write derivatives is something over something, right? The way to write the derivative of something, or the answer, or the slope, whatever, is the dependent variable, the y value, per or over the x variable. If you're just writing it in math terms, it seems kind of confusing. But if you have a question about how fast a car is going, writing it in miles per hour, right? If you're talking about how fast a water bottle is getting filled up with water, you're talking about liters per hour, liters per minute, whatever, right? So you're writing whatever the dependent variable is, or whatever's changing, over the dependent variable. Most of the time is going to be time. Another thing you have to know is that if a derivative of a function or the slope of a function is positive, it's going up. If it's negative, it's going down. We learned this in middle school when we first drawing graphs, right? Anything where it's going up, this is a positive slope. Anything where it's going down, well, this is positive for a second, but anything where it's going down is a negative slope. So just keep that in mind, keep that locked in. And we're going to look at a couple practice problems where you have to apply derivatives, and you'll see what I'm talking about. So up here we have a little practice problem. It says Charlie is driving to school. The distance in miles that he travels is multiplied by d of m, where m is measured in minutes. The first question that's asking us is, what does d of 5 equals 7 mean, right? So this just means what is this function representing? So it says right here it's representing the distance in miles that I'm traveling in minutes, or depending on how many minutes, right? So d of 5, right? It means you're replacing this m, and this m is measured in minutes, right? So that means 5 minutes in, how far am I traveling? It says right here it's 7 miles, because it says that the function represents the distance in miles that I'm traveling, right? So d of 5 means that in 5 minutes, Charlie traveled 7 miles. Right? 5 minutes in, I'm 7 miles away, because it's showing the distance that I traveled. Okay, cool. Now what does d prime of 20 mean? So the d prime is the derivative of the function. That means the slope, right? So d prime of 20 means the slope at 20. The slope 20 minutes in. So it says right here is 3, right? So this means that 20 minutes in, Charlie is driving at a speed of 3, right? 3 what? So like I said before, it's dependent variable over independent variable. So in this case, I'm driving 3 miles per minute. It says here it's measured in minutes, and it's measuring distance in miles. Of course, nobody would drive 3 miles per minute in Los Angeles. That'd be very dangerous. But in this problem, 3 miles per minute is the answer, because it's dependent variable per independent variable, and the independent variable is always going to be time. Yeah, we'll look at one more to solidify this, but this is review. Okay, so up next we're going to look at this problem here. It says that the rate that Charlie is putting on pounds of muscle is represented by m of w, where w is measured in number of workouts. So important things about this function is it's already talking about the rate, so you could think of this as already a derivative function, but it's saying that m of w represents the rate that Charlie is putting on muscle, not how much muscle Charlie has put on. That's important to see. So go ahead, answer these, write these down, or just think about them, say them out loud, whatever you want to do. Well, what does m of 4 equals 3 mean? Yeah, I just kind of said it. But m of 4 equals 3 means that 4 workouts in, Charlie is putting on muscle at a rate of 3 pounds per workout. Absolute beast. 3 pounds of muscle per workout. But the point is, it's the rate here. It's not 4 workouts in, I have 3 more pounds of muscle. It's 4 workouts in, the rate that muscle is getting put on is 3 pounds per workout. Now, m prime of 7, what happens if you derive a function that's already the rate? Since it's m prime of 7 here, it means that 7 workouts in, the rate that Charlie is putting on muscle is increasing at a rate of 2 pounds per workout So yeah, this is pretty simple, pretty similar to what we just did, but the important thing to know is that if you're looking at a function that is already describing the rate of something, it acts as if it is already a derivative. But it's also important to know that you could use these functions, you could use the position function and the velocity function, even if your functions don't represent just like distance traveled, right? Because in this case, it's pounds put on per working out. So it doesn't have to be distance. It could be any kind of function, but you could derive it and find rates and all of that. So now we're going to move on to like, you know, to like hard calculus stuff, bro.